All right. Tuesday made easy. This is going to be the 3.4 ready and the 3.4 go. The ready is, and actually I don't even think that that's the set. It should not be the set. It should be just the ready. The first three problems of the ready are really easy. It's identify A, B, and C. And as we begin to look at quadratic functions and we start thinking about using the quadratic formula, we need to be able to identify the A value, B value, and C value out of a quadratic function. If the function is in standard form, which all three of these are, and standard form is the highest power decreasing, all right, so x squared, x, so on. If it's in that form, then the A, B, and C values are easy. A and B are coefficients. What is a coefficient? A coefficient is a number that coexists with the variable. C is a constant term. So A being the first value, in this case being 1, B is 3, C positive 2. And you always got to look to the sign in front of the number to tell you what it is. Number 2, what is A? If you said 2, you're correct. B, the B value. If you said 3, you are correct. C, if you said 1, you are correct. And finally, question number 3, identify A, B, and C. Take a second, see if you can do that one. You should get 1, -4, -12. Anytime you do the quadratic formula, the first thing I'm going to have you do is identify your A, B, and C value. List them. You have to know what they are before you put them into the formula. All right? So you have to know that. The second part of this is factor, and you need to make sure you pay attention to the directions because my directions are different than what the book says. All right? There's, what I believe, 9 problems there. My directions are pick a minimum of 2 from each row. Right? So you only have to do 6 of them, but you have to pick at least 2 from each row. How do we factor? Well, remember, we multiply A times C. We list our factors of the last term, so 1 and 2. 2 is a factor, it's already listed. That's it. Which factors add and how do they add to give me 3? That's what I use to expand the problem. So x squared plus 2x plus x plus 2. When A is 1, the coefficient out there is 1. These become my factors. Well, again, it should be reasonable that in order to get to here, I would have had to have started with 2 sets of parentheses. If I'm factoring, which is dividing, I should end up with 2 sets of parentheses. So x plus 2, x plus 1. All right? Here is my first factor. This 1 over here that's not written, that's my second factor. So there you go. Number 5 is a little bit different. 5 is different in the fact that the A value is 2. So how do I handle that? Well, the answer to that is a little bit lengthy, but we're going to get there. We do as instructed over here. We multiply A times C. So 2 times 1 is 2, and I'm going to list my factors of 2. So what are my factors of 2? Well, gee, they better be 1 and 2 just like they were over there. I want factors that add to give me 3. And how? Positive 3. Both need to be positive. So that's what I'm going to use to rewrite this problem. So 2x squared plus, it doesn't matter how I do this. I could put plus x or plus 2x. 2x plus x plus 1. So I've expanded. I've taken that 3 and my factors tell me how to divide that up. Now I group. This is factor by grouping. Anytime you have an A greater than 1, factor by grouping is what you want to do. So now I'm going to go ahead and group. Make sure you understand that this third term is positive or negative. I know it's positive. That's why I kind of crossed it out, so it didn't matter. Now I'm going to take out the greatest common factor. Now I GCF. Right? So the GCF in this case is going to be 2x. And when I divide 2x out of here, what do you get? 2x squared divided by 2x. Remember, that's what I'm taking out. I'm left with x. 2x divided by 2x is plus 1. The factor by grouping process is my other set of parentheses need to be the same as what's here. Well, that's already there. What do I factor out? I have to factor something out. The answer to that is you're going to factor out a 1. Dividing by 1 doesn't change anything. I have to divide something out. and I have to put something here. I want x plus 1. Division by 1 doesn't change anything. Two sets of parentheses the same. You know you factored correctly. What I take out, 2x plus 1 is one factor. What is in parentheses, x plus 1 is the other factor. And there you go. Right? That's the hardest one of this whole group because it's the only one that has an a value. The rest of these you need to factor. So you got 4 more you have to do. And then the last one, 23 through 26. You are not going to do 24. We're not going to do 24. This is a good little review here. It says find the x and y intercepts if they exist and then use them to sketch the function. So I want to find my x and y intercepts. The very first problem I'm going to look at is I'm going to look at the first one here. F of x is equal to x plus 5 and x minus 4. Now, this is in factored form, and this is good because we have factored form, we have another form in 25, which actually ask yourself if that's a linear or quadratic function, and then we have 26, which is in vertex form. If it's in factored form, what tells me the x-intercepts? You have to think, okay? And this is why it's a good review. We see something a while back, we get conditioned to it, we forget about it, and we do something else, and now we come back to it and go, hey, how can I figure this out? Well, remember, my x-intercepts are the opposite of what my factors are. So here, if y is 0, which on an x-intercept, I'm not going to move up or down at all. So if I come out here a certain number, 1, 2, 3, 4, 5, if I come out, let's say -5, I don't go up or down, that means that this has an x value of a number, which is -5, and a y value of 0. So I'm using that to my advantage when I find my x-intercepts. Well, my x-intercepts are the opposite of what my factors are. So +5 here, so one x-intercept is going to be -5. The other factor is x minus 4, so that means my other x-intercept is +4. So -5 and 0 and +4. 1, 2, 3, 4. Here's my x-intercepts. My y-intercept. How do I determine my y-intercept? That's going to be easy. That's the product of the last two factors in a. So I'm going to say 5 times -4 times 1. Okay? Product of the last two factors in a. So this is going to give me -20 is what that's going to work out to be. I'll just put this over here. So my y-intercept is going to be 0 and -20. That was pretty easy. I mean, if you go through and multiply this out and put it in ax squared plus bx plus c form, remember that c is the y-intercept, you would get -20. Think about how c is. C is the product of the last two factors and the a value. In this case, a is 1. So here's my y-intercept, which y, that's going to be way down here. Okay? Now it wants me to graph it. Well, I need to know where the vertex is. Where's the vertex? Remember, the vertex, if I know my x-intercepts, the vertex is halfway between these 2 points. Well, -5 all the way to +4 is 9. That's 9 units. 9 divided by 2 is 4.5. So 4.5. I'm going to go 4.5 units to the left, right here. That means my vertex is at -0.5 and something else. It's close. I'm somewhat close. So I'm going to come down here, probably come back up. At least it's going to look similar to that anyway. And there's going to be my vertex. All right. Try the other ones, 5 and 6. If you have questions on those, please ask. We'll get those taken care of probably in class. But for those of you that weren't here, you need to make sure you ask and ask some questions. All right.